Hello and welcome back to Civil Engineering Tutor. In this video, I will continue to explain most important MCQs for RCC which are repeatedly asked in any competitive exams. So this video is going to be very helpful for your preparation or your revisions for any junior engineer and assistant engineer exams like SSC Junior Engineer, RRB Junior Engineer, GATE, Engineering Service Examination, and different state public service commission junior and assistant engineer exams. So this is actually part 2 of this RCC MCQ series. So if you have not already watched part 1, then you can watch it first, or you may watch after watching this part 2 also. The link of part 1 is given on the description section, or you can simply go to our playlist section and watch the RCC playlist section. You will find it there also. So let's start this video. So in part 1, we have discussed 5 important concepts and total 33 questions are covered and their answers are explained. In this part 2 video, we will start from concept number 6 and we will start from question number 34. So at first, I will discuss the concepts and then we will see questions one by one and try to find their answers. So let's start with question number 34. So here it is said that unfactored maximum bending moments at a section of a reinforced concrete beam resulting from a frame analysis are 50, 80, 120 and 180 kN under dead, live, wind and earthquake loads respectively. So unfactored bending moment has given for dead load, live load, wind load and earthquake loads respectively. The value is given. Now we have to find out the design moment as per IS 456 for the limit state of collapse flexure condition. Okay, so here we have to remember that there are two types of limit state. One is limit state of collapse and another is limit state of serviceability. Now the concept is that this is unfactored maximum bending moment. So at first what we need to do is we need to factor it. That means we need to transfer this working bending moment into ultimate bending moment. So how to transfer this unfactored maximum bending moment to design bending moment, we will see. Here is the reference. So for the collapse condition, we have these multiplication factors, and for serviceability, we can see here is the multiplication factor. So at first, there are 3 possible scenarios given here, that at one critical condition can be when dead load and live load is acting together. For that case, in collapse, we will multiply the summation of dead load and live load with 1.5. And for serviceability criteria, the multiplication factor will be 1. When dead load and wind load, and always remember here one thing, that in design, it is assumed that wind load and earthquake load does not act simultaneously. This is very rare situation. That's why it is assumed that wind load or earthquake load will act, but never wind load and earthquake load act together. Okay, so just remember, either you will take wind load or earthquake load. You have to select only one, not both of them. So dead load and live load can act together. Dead load and wind load can act together, but wind load and earthquake load can never act together as per the assumption of this design. So here, when dead load and wind load or earthquake load factor is taken, then we have to multiply this with 1.5 for normal cases. And for when we are checking stability against overturning, like for designing a dam, in that case, that this dead load plus wind load summation can be multiplied with 0.9. So that's a different case. Now number 3 is when dead load, live load, wind load or earthquake load, when these 3 loads acting simultaneously, at that case we have to use this 1.2 as multiplication factor. So we'll see this problem and then your concept will be very much clear. So here the values for different loading has given moment, unfactored bending moment. So dead load, for dead load it is 50 kN/meter, for live load 80 kN/meter, wind load is 120, and for earthquake loading it is 180 kN/meter. So if we see the first combination, that dead load and live load is acting together. So here the multiplication factor is 1.5. So here design bending moment mu is equal to 1.5, dead load bending moment due to dead load and bending moment due to live load. So here the factor is 1.5. So we have used 1.5 here. Now what is the value of dead load bending moment? 50 kN and live load 80 kN. So simply putting these values, we will get the design moment for this case. Number 1 case is 195. Now coming to the second case, when we have dead load and wind load or earthquake load combination, and we have to multiply it with 1.5. Now remember here one thing, we can see that we can take either wind load or earthquake load. Now the value of wind load is 120 only, but earthquake load is 180. So we have to take always the maximum value, either So in this case, earthquake loading has the maximum value. So we will take only earthquake loading case because this will be the critical scenario. So here 1.5 into dead load 50 and earthquake load 180 kilonewton meter. So this second case, design moment will be 345. Now in the third case, that is this combination, when we are taking dead load, live load and wind load simultaneously. In that case, we have to multiply it with 1.2. So here we have multiplied it with 1.2 and these are the corresponding values. So we can see the bending moment due to dead load 50 and that putting this corresponding values, we will get here the case 3, the design bending moment is 372. Now we have to take the maximum bending moment from these 3 cases. So here the maximum bending moment is coming from case number 3. So this will be the design moment. So 372 will be the correct answer. So we'll see here D is the correct answer. I hope you understood this problem. Now similar type of problems. So here the same kind of problem, dead load and live load and seismic load, the corresponding bending moment as given. So we need to find out the design bending moment. So simply 3 criteria will be there. So let me put these values first. Now case 1 will be 1.5 dead load and live load combination. So here dead load value is 20 and live load value is 30. So 20 plus 30 is 75. So that is one case. Now case 2 is 1.5 dead load plus earthquake load. So here dead load is 20, earthquake load is 10. So the value will be 45. Now the third case is 1.2 into dead load, live load and earthquake load combination. Here the value is coming 72. So maximum value is coming from case number 1. So the design bending moment for limit state of collapse will be answer B, 75 kilonewton meter. Hope you understood this problem. Now coming to next question, question 36. So here this is theoretical question. They have just asked that which is the correct combination of this loading. So the factored loads at the limit state of collapse for dead load plus live load, dead load plus wind load, and at the combination according to IS 456 are respectively. So which of the combination here is correct? So we'll see one by one. So at first dead load and live load 1.5. So this is correct. Now this one is not correct. 1.2 dead load plus 1.2 wind load, because 1.2 is only considered when all the 3 loading is acting together, not just 2. So this will be obviously cancelled out, and we can see that. So this A will not be the correct answer. Now coming to the B, 0.9 or 1.5 dead load plus 1.5 live load. So when dead load and live load is acting simultaneously, in that case the multiplication factor is 1.5. So obviously this option is also not correct. Now coming to the option C, 1.2 dead load plus 1.2 live load. Obviously we can see that dead load and live load combination is 1.5. So this is also not correct. So obviously the question option D will be correct answer. And we can see here 1.5 dead load and live load combination, 0.9 or 1.5 dead load plus 1.5 wind load. So correct. And 1.2 dead load, live load and wind load. So this is correct combination. So correct answer will be D. So moving to our next question. This question is come in ESC 1998. So here combination for limited state of collapse and limited state of serviceability is asked. So we can see without further discussing that option C, where dead load and live load 1.5, 1.5 dead load and wind load, and 1.2 dead load, live load, wind load. So this is correct for limited state of collapse. And for serviceability criteria, we can see dead load plus live load is 1, okay, or 1 dead load plus live load we can see, and dead load plus 0.8 live load and wind load. So this is C will be the correct answer here. Question 38, similar kind of, here the thing is which of the following load combination is not considered. So we have to understood that this is not considered is option. So the wrong one will be the correct answer. So this is obviously right answer, 1.2 dead load, live load. This one will be incorrect because when 3 loading and obviously wind load and earthquake load never act simultaneously. So this C will be the not considered combination. Now question number 39, and this is another concept, that is concept number 7. So let me read this question first. The maximum strain in concrete at the outermost compression fiber in the limit state design of flexure member is as per IS 456. Okay. So the maximum strain in concrete at the outermost compression fiber. So this is very theoretical question and very important. You have to remember this value 0.0035. So here correct answer will be 0.0035. Just remember this value. Moving towards question number 40, similar kind of question. So here also the limiting compressive strain of concrete and bending, obviously option A, 0.0035. Here comes another question. As per IS 456 1978, the ratio of stress in concrete to its characteristic strength at collapse in pleasure or design purpose is taken. So which one is the correct answer? So we know that design stress or design strength is equal to what? 0.45 FCK, and that comes out from this expression that we know that while testing cube the strength is FCK. Okay, now when that strength is transferred in any structure, because cube has a limited size and you have a structure which is much bigger than a cube, so obviously if you are getting strength FCK in case of cube compression testing, you will not get the same strength on a bigger structure. Okay, like you have a residential building of one floor, so or a beam which has a higher dimension as compared to a concrete cube. So it may be like 1 meter or 10-meter length of that beam. So when we are increasing the dimension, the strength is obviously reducing, and that is 0.67 FCK is generally considered when slenderness ratio is greater than 4. So this is because of size effect, we reduce the value of strength to 0.67 FCK. And then further we know that we have to apply 1.5 as a factor of safety for concrete. So in this limit state method of design, we use 1.5 as a factor of safety. So here the final design value will be 0.45 FCK. So the correct answer will be 0.447 FCK or 0.45 FCK. So C will be the correct answer. Similar question, the maximum compressive stress in concrete for design purpose 0.446 FCK or 0.45 FCK. So this graph you can see that FCK is the characteristic strength in concrete cube. So when we are testing a cube, that strength value is FCK. This is the graph for that case. Now cube has limited size. What is the size of cube? 150 mm by 150 mm by 150 mm. Okay. Now when we are testing a much bigger dimensions or much bigger concrete element like a beam which has length of 5 meter or a column which has height like 3 meter, so the property will not be same as of concrete and the strength will obviously reduced in that structure. So we are taking 1.5 as a factor of safety. So FCK divided by 1.5 is equal to 0.67 FCK. So this is the characteristic strength of a concrete in actual structure. Now while designing, we already know that factor of safety of 1.5 is applied in design process. So if we know that actual strength of actual structure is 0.67 FCK, then we need to further divide it by that factor of safety of 1.5. So the value will be 0.45 FCK, then that will be the design strength. So here the maximum compressive stress in concrete for design purpose, it will be 0.446 FCK or 0.45 FCK. Now if they have asked here that the maximum strength maximum compressive stress in concrete in actual structure, then it will be 0.67 FCK. So just remember this. So for design purpose, we will take 0.45 FCK, but in actual structure, this will be 0.67 FCK. Okay. So here, this one is the correct answer. Moving to our next question. Now, the maximum strain in concrete in compression bending, we have already seen this 0.0035. B will be the correct answer. So minimum strain, the formula for minimum strain of steel is this one. EST is equal to 0.002 plus 0.87 Fy by ES. So we have to remember this formula, where Fy is obviously, you will know that this is the grade of steel, and ES is modulus of elasticity of steel, that is 2 into 10 to the power 5 megapascal. So let's see the answer of this question. This question is asked in ESC 2011. So here Fy is already given 400 MPa. So simply we will put the value Fy is equal to 400 and we will put ES is equal to 2 into 10 to the power 5. So here simply putting Fy is equal to 400 and ES is equal to 2 into 10 to the power 5, we will get EST is equal to 0.0374. So the correct answer will be obviously option C. So you can see the correct answer is option C. Now the same type of question, minimum strain at failure in tension steel, having yield stress is given and Young modulus is given in this case. So simply we have to put Fy is equal to 415 and ES is equal to 200 in this formula. 200, that is in gigapascal, so we have to transfer it into megapascal. So that will be 2 into 10 to the power 5 megapascal. So simply putting this value in place of Fy, we will put 415 and then we can see that this is the minimum strain is equal to 0.0038. So option B would be correct. This is asked in Engineering Service Examination 2015. Question number 7. So this is 47. This is very theoretical question. You just need to remember the answer for the as of now. We will discuss this when we will discuss strength of material chapter, and the we will see different collapse theory. At that time we will discuss about this different theories. So just remember this. So here the RCC design, the failure criteria for reinforced concrete beams and column is based on maximum principal strain theory, and we have already seen that what we have tried to find in these previous problems. We just only tried to find the maximum strain and minimum strain for two different materials, that is one is concrete and one is steel. So it is completely based on strain. So we have to remember this is maximum principal strain theory. Okay, now here one different types of question. The maximum depth of stress block for balanced section of beam of effective depth D using steel with Fy is equal to 250 is given. Here this is very ready-made. I think most of you have already memorized this type of problems. So here is the answer. You have to remember that the ratio of XU max by D, that means the maximum depth of stress block, okay, by divided by total depth, that is given by strain in concrete by strain in concrete plus strain in steel. Okay, and the final formula comes out like this: 700 by 1100 plus 0.87 Fy. So for three different grades, 250, 415 and 500, the corresponding XU max value is given here. Just to save your time, you should remember this formula. So XU max is 0.53D for 250. So here grade is 250, and this is asked in SSC 2011. So correct answer will be B. Now similar type of question for iron 415. So correct answer will be 0.48D. So here answer will be B. Now another question is stress strain curve of concrete is. 4 option is given. So before reading these options, let me discuss this graph for stress strain curve of concrete. So you can see this is the design. This is the graph for cube strength. This is for actual structure, and this one is for design purpose. Okay, so clearly we can see that in all three the initial part is parabolic, and then after certain strain the variation is linear. Okay, so we can see here that correct answer will be nearly parabolic up to 0.002 strain value, and then a straight line up to failure. So here you have to remember this, that value is parabolic up to 0.002 strain and up to failure, that means 0.0035. That variation is linear. So the correct answer here will be C. Now question 51, the design stress for mild steel in limit state design method is taken as. So we already knew this in the part 1 video of this RCC MCQ series, that the factor of safety for steel is 1.15 in limit state design method. So we will simply divide the characteristic strength of steel by that factor of safety. So here design stress will be Fy, or characteristic strength by factor of safety, is 1.15. So it will come out 0.87 Fy. So correct answer will be D. So now coming to another question. This is very much conceptual again, and you need to visualize it to understand. This is like, if you can visualize, you can easily understand this problem, that section or a plane which is normal to neutral axis before and after bending, that means there is a chance that uniform strain is happening over the beam cross section. So just remember this question 52, that the basic assumption of plane section normal to the neutral axis before bending remaining plane and normal to the neutral axis after bending leads to uniform strain over the beam cross section. So just remember this. So this is GATE 1995 question. So that's it for part 2 video, and at the end of this session you can see that quiz of the day is there. So if you know the correct answer of this question, already I have discussed like 20 or 25 questions. So now it's your time to check whether you know the answer of these questions or not, and how your preparation is going. So if you know the correct answer, just comment down the correct answer in this below this YouTube video. So which one of the following states falls under the limit state of serviceability as per IS 456? Stability under load, loss for equilibrium of structure, load vibration, and formation of mechanism. So if you know the correct answer, comment down below this video. So if this video is anyway helpful to your preparation or your revision, it may be possible that you already know these questions, you already know the answer of these questions, or you have already solved this earlier, but watching this video is certainly helping you to revise it once again. So just like this video, your like is giving me motivation to make further videos, and subscribe to our channel for latest job update as well as daily preparation related videos on SSC, JEE and different competitive exams. So thank you very much for watching this video.